try. We are given this polynomial x to the fourth minus 6x to the third plus 12x squared minus 8x equals 0. And they say that we can use rational zero theorem, Descartes' rule of signs, theorem on bounds as aids in finding all real and imaginary roots. Well, they don't say we have to use them. I think I might try something. Something just dawned on me. I wonder, there are 4 terms on the left. I wonder if we can just factor by grouping and just get right to it. I'm not sure this is going to work, but let's give it a try. Out of the first 2, we are able to pull out a common factor of x to the third power, and it leaves x to the first power minus 6. I don't know if it's going to work here, though. Here we can pull out a common factor of 4 plus 4x, and that leaves 3x minus 2. I don't see a miracle happening there. Okay, so bad idea. It might not be a bad idea to try to swap the 2 middle terms and try again. X to the fourth plus 12x squared minus 6x cubed minus 8x equals 0. Now let's try it again. Out of these 2 dudes, we can pull x squared. It leaves x squared plus 12. Nope, ain't gonna work. Because over here, out of these 2 guys, we can pull negative 2x, and that leaves 3x squared, and then a plus 4. Nah, another bad idea. All right, let's get to work. Let's try rational zero theorem. And that's where we make a list of p's over q's. P over q equals plus or minus. We're going to put all of the factors of the lead. No, oh, you know what? We can actually do something with this. We can pull out a common factor among all of those dudes. They have a common factor of x. So we have x times x to the third minus 6x squared plus 12x minus 8 equals 0. Very nice. And that means that we already have one of our roots. We have one of our roots here with the x, but we won't worry about that right now. We'll worry about factoring the stuff inside the parentheses. So the constant coefficient's negative 8. So the factors of that would be 1, 2, 4, and 8. And the lead coefficient of the coefficient of x cubed is just 1. So that gives us this list of possible rational zeros, plus or minus 1, 2, 4, 8. Okay, let's test them. Let's test them on x cubed minus 6x squared plus 12x minus 8. We do that by synthetically dividing. So we'll start with 1. Synthetically dividing, we have the coefficient of x cubed, the coefficient of x squared, the coefficient of x, and the constant coefficient. Make space, make a line, bring down the first number, multiply 1 times 1 is 1, add negative 5. 1 times negative 5 is negative 5. Add 7, 8, 9, 10, 12. 1 times 7 is 7, add negative 1. Okay, what we got here has alternating signs. That's not important, though, because we know that if the number we were dividing by was negative, it would be important if we had alternating signs. So this doesn't tell us anything. It's certainly not a root, because it does not have a 0 remainder, so it's not a root. Well, that's okay. Let's try the next one. Let's try 2. 2 synthetically divided into 1, negative 6, 12, negative 8. Make space, draw a line, bring down the first number. 1 times 2 is 2. Add negative 4. 2 times negative 4 is negative 8. Add, you get a positive 4. 2 times 4 is 8. Oh, good news, good news. Happy face 0. This means, yes, very good news. X equals 2 is a root. Okay, so let's take what we had before. That's this guy right here. Let me put a little cloud around him. He's important. Take that guy, bring him down here. He was x times x cubed minus 6x squared plus 12x minus 8 equals 0. But we were able to factor further, so now we have x times x minus the root that we just found, 2, times 1 degree lower from x cubed would be 1 times x squared minus 4x plus 4 equals 0. And we can factor by guessing. Factor that part by guessing, because it's second degree. We'll try. If we can't, we'll use another method. Guessing. So we'll get x, and by the way, x is the same as x minus 0, times x minus 2. Okay, factor by guessing. So we have x here and x here. And then we'll have a minus 2, minus 2. Let's see if that's good. First times first is x squared, last time, oh yeah, it is good. So if we write this in its exponential form, it would be x minus 2 to the third power. And that would give us 0 is a root with multiplicity 1, so it counts only once. And we have 2 is a root with multiplicity 3. So what that means is we have found all of our roots. Because it was a degree 4 polynomial. And you'll notice we didn't have to use a lot of the stuff they suggested. We just got right to work and started doing synthetic division after a couple of bad ideas.